Hello everyone, good morning to one and all. Today we have gathered here to gain a hands-on experience on real-world usage of IoT, that is Internet of Things. I welcome you all in this amazing workshop, Pathway to Hardware. Today, myself, Gar Mittal and Yuvraj Singh will be taking this workshop. We are from IET VIT, from TFD domain, Team 4th Dimension. Now let's see the flow of this amazing journey. In this session, you will be learning about the basic hardware components such as microcontrollers and microprocessors. Next, we will dive deep into IoT, its features, real-life uses, and much more. By the end of this session, you guys will be able to make your own Arduino project, which will be doing with an online simulation tool, Tinkercad. And as a bonus, we will also demonstrate one of our own project which made us win an hackathon. So moving on, let's talk about microcontrollers and microprocessors. Microprocessors. Let's start with something interesting, okay? I know many of you would have heard this term microprocessors. So please comment in the chat box which microprocessor is there in your PC. For those of you who don't know, you can simply search about this PC and get info of the available microprocessor in your PC. Copy that and let's see what different kind of microprocessors you have. Okay, so moving on, let me explain you what microprocessor is. In simple words, it is used for very intensive processes. Microprocessors are not made for a specific task, as well as they are useful where tasks are complex and tricky, like development of software, games, and other applications that require memory and where input and output are not defined. All right. So now understand the same with the help of some daily life examples, like household devices. We just now saw that like home computers have microprocessor embedded in them. Similarly, complex home security system also have microprocessor is in them. The next we can discuss about transportation and industrial devices like planes. We know that they have to take complex decisions based on the sensor input and all. They need to do complex calculation and finally give us an output. So there also we need a microprocessor in them. Did you notice all the above applications are complex and they need to process complicated data? All right. So moving on with microcontrollers. Microcontrollers are designed for a specific task or to perform the assigned task repeatedly. Once the program is embedded on a microcontroller chip, it can't be altered easily. Like if we want to alter it, there are some special tools required for it, and we need to rerun it, and it's a tedious process, not easy to do. So like they can work in a specific domain only. For example, calculator, that it can only deal with numbers and nothing else it can do. Similar examples are washing machine, ATM machine, robotic arm, etc. All right. From here on, my friend Yuvraj will be taking over and explaining you the IoT basics. Yuvraj, over to you.
Hi everyone, I am Yuvraj Singh, and from now I'll take on. So, IoT, Internet of Things. So, at first I would like to say, talk about what are things, like what does in generally things mean. Like things are the basic appliances which you use in your day, such as fan, bulb, or like that thing. And when these things are connected to internet, a network of all these appliances and things make this IoT, that is Internet of Things. Okay, so like you can control all these things from anywhere in the world. Like the basic requirement is just that those things must be connected to the internet. Okay, so moving on, we'll be talking about features of IoT. So the very first feature that IoT provides us is connectivity. Suppose let's take for an example, if you are connecting your fan through IoT, then it is providing a connectivity between you and your fan. Like just by simply pressing on your smartphone, your fan will be turned on, right? So IoT provides us connectivity between different things or application appliances, right? And the second thing IoT provides, the second feature that IoT provides us is analyzing. Suppose let's take for an example, the weather data, how that weather data and rain prediction are made, right? By analyzing the different sensors data such as humidity sensor data or temperature sensor data, whatsoever data is getting collected, then the data is processed and analyzed to predict the rain. Like if the humidity is this much and the temperature is this much, and the rain percentage, like the prediction, the chances of coming rain is about this much percentage, right? And the third feature of IoT is active engagement, right? So IoT provides us a very active engagement with different technologies, right? Like we can use IoT with multiple domains. Like we can use IoT with blockchain, IoT with machine learning, artificial intelligence, and many more. And the fourth feature of IoT is scalability, right? And now we can see that each and every day, many elements are getting connected to IoT. Like in previous 25 years, no one would have thought that they will be able to control their fan just through a smartphone, or like they would be able to track their car just while sitting at the home, right? So the IoT is getting into more and more domains, right? And the fifth feature that IoT provides is like we can use IoT in artificial intelligence also, right? So let's take for an example, there is a coffee machine, right? So coffee machine requires some coffee beans inside that. Okay, so in a normal user without IoT, if he is using that coffee machine, right? So then he need to see that if the coffee beans are getting over, or what is the status of those coffee beans, like, right? Like if they are about to over, then he need to go to the shop, purchase new ones, right? But if we use artificial intelligence in that, then it will automatically see that what is the status of coffee beans in that coffee machine, and it will automatically over, like if those coffee beans are about to over, right? So moving on, what are components of IoT? Like IoT is made up of what all things? So the first and the most important component is sensors, right? So sensors are the sensor works at the ground level of IoT, right? Like these are the only ones which will collect the data from different sources, right? Like suppose if you are using humidity and temperature sensor, then they will collect the data of humidity, what is the level of humidity in that, and temperature in that particular area, and then they will collect the data, right? And then they will send to the microcontroller. So, and the second component of IoT is connectivity. So, like if we are using IoT, that is internet, then until and unless these sensors and microcontrollers are not connected to internet, then it is not a part of IoT. So, it is important that they all must be connected to the internet, right? So, for that we need different kinds of connectivity modules, such as Wi-Fi modules we can use, Bluetooth modules we can use, and GSM based modules also we can use, and we can use. And the third component of IoT is data processing, right? So whatsoever data has been collected through those sensors, right? We need to process that data, and we need to analyze that data, and give an output based on those values which those sensors has collected, right? Suppose if humidity and temperature sensors are collecting the data, need to predict the rain, right? Then if this much is the humidity and this much is the temperature, then the percentage of rain will be this. Then the data needs to be processed, right? And the fourth and last component of IoT is user interface, right? The user will not be able to see what is happening in this data processing, what is happening in this connectivity and the sensor, and how these sensors are taking data, but he will be only able to interact through his phone, right? Like he must see that what is the status of his what is the temperature, like what is the rain like status of rain today, like how much are the chances of coming rain, right? 33% and all. He will not see the temperature, like he will not see the whatsoever data has been collected by those sensors, right? So user interface of any IoT component must be very easy to use, so that every novice user can understand that. And so moving on, we'll discuss how does the IoT works. Okay, so as I told you earlier, these devices and sensors, whatsoever sensors are there, they collect the data, right? And then they send the data to microcontroller or microprocessors, right? Which and those microcontrollers and microprocessors are connected to Wi-Fi module or Bluetooth module, which helps them to share that data to the cloud or the central database where anyone can access, right? Once the data is stored in the cloud, then anyone can access that data, through the different API keys. Mobile apps use different API keys to fetch that data from the cloud, right? And then that data could be presented to the mobile devices, or like if anyone is using the IoT sensors in a large area, then they can see from their control room. From at that place also we can fetch the data. Okay, so the very basic microcontroller which is used in the Arduino in this IoT, everyone uses, like Arduino is the one of the cheapest microcontroller that you can buy as a beginner. Like if you want to get started with all these sensors and microcontrollers, then Arduino is the best thing for you. So basically, it is a microcontroller. It contains everything that needs to be supported in the microcontroller. It has 14 digital input and output pins. Okay, and it has 6 analog pins, where you can get the analog data also from these analog pins. Okay, and it has a 16 megahertz ceramic resonator through which you can connect this Arduino to your PC, right? So, and you can upload the code also in this microcontroller, that so that whatsoever in which one you want to get the data, or from which pin you need to send the data, everything you can do that. Okay, so to program this Arduino Uno board, there is an open source software, Arduino IDE, which is an free to use software. Like anyone can download that, and we can write code that we can code that Arduino this Arduino using that IDE, and we can simply upload that into this Arduino board. Okay, so the next microcontroller is our NodeMCU, ESP8266 NodeMCU. The one which you can see in this photo is an embedded Wi-Fi plus microcontroller, which means like it can do work of both, right? It can connect also to the internet, and it can work as a microcontroller also, right? If you take the only Arduino, then it does not have any embedded Wi-Fi chip in it, which is the drawback for it, so that it can't be connected to the internet directly. Like we need a separate Wi-Fi module for Arduino to connect it to the internet, right? But in NodeMCU, the very important, the very fascinating thing is this only. You can use it as microcontroller also, and there is no need for a separate Wi-Fi module, because ESP8266 Wi-Fi module is already enabled in this NodeMCU. Okay, so, the only drawback of this Node MCU is it only contains some 6 to 7 digital input output pins and only one analog input pins. So it fails when you need to access the data of multiple sensors, right? Like then the six digital input pins won't be useful, right? You need more input pins. So in that condition, you can use this ESP8266 Node MCU with Arduino Uno. Like you can connect both of them, and can they both can send the data to the internet, right? Like once this Arduino will fetch the data, and it will use this ESP8266 as a Wi-Fi module to send the data. Okay. So moving on next, we'll see how this Arduino and NodeMCU works as together, right? So a supply of plus 5 volt and ground is provided by the Arduino to each and every sensor, right? Okay, and then the digital data incoming pins of all the sensors, all the sensors have mainly three pins. Okay, one is the ground pin, and one is the plus 5 volt pin, from where you are taking the providing plus 5 volt current to that voltage to that sensor in order so that the sensor can work properly. Okay, and many sensors have more than one data pins, but data pins are also there. So and from those data pins only we are getting the data from that sensor. Okay, so that the digital data incoming pins, like they all are connected to the incoming pins of this Arduino, and we can fetch the data from the same. Okay, and then that Arduino sends all the data which has been collected from those sensors, right? It sends it to the NodeMCU, right, which is a Wi-Fi module, which is only connected to your internet. Okay, and internet means here I means like your cloud, right? Like on the internet or whatsoever database you are using. Like mainly we use Google Firebase, okay, because it is easy to store in this Google Firebase from NodeMCU, and you can fetch also in your smartphones, right? Like in your app if you are good in this app development. Then okay, so now moving on, I'll hand over the which he will explain the advantages of. Over to you, Gaurav.
Yeah, advantages of IoT. Now let's see some of the like good side of IoT. First one is improved customer engagement. Like it, for instance, like IoT facilitates a better customer experience by automating tasks. For example, there if IoT is enabled in a car and like the AI detects there is some issue or like some part is going to be faulty soon, so it can send a message to both manufacturer and the user so that they can be like aware of the same. Okay. Next is technical optimization. IoT has improved technology and made it more efficient. It has turned even an old dumb device into smart ones by making them able to transmit data over the internet, like facilitating communication with people and other IoT enabled devices. Some of the example for this are coffee machine, smart toys, smart microwaves, etc. Ease of access, like we can access information from anywhere in the location. All we need to have is an internet connection. Like for example, if we are going on a drive and after 1 to 2 hours of driving we are like not sure that whether we have closed the light of the switch of the light of the bedroom or not. So like if we have IoT enabled in our home, and we can check that from anywhere in the world, like while even on our mobiles. The next is new business opportunities. We know that IoT devices are like 24/7 on, and they collect a huge amount of data. By collecting this data, we can uncover new business insights and generate new opportunities while reducing the operational cost. The last but not the least is effective time management. Like we all know that IoT has like made us save a lot of time. We can while we are going for work, we can view the latest news on our phones and browse a blog about a favorite hobby or shop online, etc. So that's it about the advantages of IoT. Now let's discuss some dark side of the same, the challenges in of IoT. Okay. Challenges of IoT. The first one is privacy. Since the IoT devices are 24/7 times on, like we cannot uh, we cannot rely completely on them and have a like definitely there is a privacy concern over there because they can collect some data which we don't want to be over the internet. Second is insufficient testing and outdated product. Since in currently in IoT there is not like proper guidelines which device can be called IoT and which not. So like companies don't correctly check the device and release it in the launch it in the market. Because of that there are some issues, like they send data in an unencrypted form over the internet which can be hacked easily. Third is lack of knowledge and awareness. Even some devices are available but the people aren't aware of the same and can use the it to the full potential. Okay. The fourth one is network connectivity. Like in a country like India, we do not expect 24/7 like constant power supply and a good internet connection. Because of that, like IoT is not we can't use IoT to a great extent in remote areas or so. The last is reliability, as we already discussed. Like we cannot rely completely on them because IoT devices send some of them send data in unencrypted form over the internet, which can be hacked and like can be very bad for us. Okay, now moving on, we will be doing a Tinkercad project in which you will be able to make your own Arduino project. We all here on Yuvraj will be taking over. Thank you.
Okay, so like, can you, as you can see the link in the chat box, right? Tarun, can you please share that Tinkercad link? So everyone, please open this tinkercad.com. In there, please see, like, I'll show you step by step how you need to do that. Okay. So once you open this tinkercad.com, then you need to make an account over here. Okay. So we'll be waiting until all make the account. Okay, we will wait for some time so that once your account is done. Once you make your account, then please type in the chat box that made an account so that we can see like you have made an account. Okay, then we can start. Okay, so I can see that some of them have made an account. So once you have created an account, then you need to click on circuits. First come to the circuits and then create a new account or create a new circuit. Okay. So we'll at first we'll make a simple LED blinking program. Okay, a simple LED blinking program. So first let it open. Okay, it is open. So for that, you need to come over here in the component section, basic, and then you need to type Arduino. Okay, then take this Arduino and keep it here. Okay, and come. Okay. Once Arduino up, so as you can see on my screen, this is the basic Arduino, what is available in the market also. We'll be doing an online simulation only, okay? So as you can see, these are these digital pins of this Arduino. Okay, these all are the digital pins, and these are the analog pins. And here we have VIN pin and ground pin and plus 5 volt pin and plus 3.3 volt pin and reset pin to reset this Arduino and all. So basically, this is our USB resonator. From here, we connect our this Arduino to our system. Okay, in our Arduino ID. So now what we'll do, we'll attach an LED with this Arduino. Okay, so I'll take one LED and I will put it here. You can also change the color of this LED to green or something of your wish. Once it is done, then it is all. Then to get the to connect this LED with this thing, this Arduino Uno, okay, you need a resistor because this is just an this LED works on only this 1 volt, right? And if you provide directly 3 volt, then this LED will be like bursting out. Okay, there will be a short circuit and this LED will burst. Okay, so you need to connect a resistor with this LED so that it won't burst. So this cathode part of this LED, you need to connect it with ground pin of this Arduino. Okay, and I'll change the color to the black so it will be easy for you to understand what is plus and what is minus. Okay, so once you have connected this cathode to ground, then you need to add this positive part of this to pin number 13 or any digital pin you can connect. There is no any compensation in that. Any but in digital pin only you must connect. Okay, I'll give this as red color. Okay, so our circuit is ready. Okay, simple blinking program we are going to upload such that like this LED will blink, turn on and off, turn on and off. Okay, it will be blinking. Okay, So now we need to write the code. Okay, when you will click on this code, then you'll get this window. Okay, from here, from blocks, you must go on text. Okay, and continue. So a basic LED program is already available for us, but we won't use it. I'll tell you one by one. At first, you need to declare in variables like this Arduino IDE also uses same language as your C++ and all like are based on, right? Like it is also based on C++. In this also there are functions that there are in variables, methods called all these functions and all. So at first you need to declare the variables, right? Variable for this LED. Okay, so I'll use as an int LED, and you need to tell this Arduino that on which pin this LED has been connected. We have connected this LED on pin number 12, right? Okay, so I will put 12. Okay, int LED 12, and after that we have declared our pin. We will set up this LED pin. Okay, like we need to set up this pin like what it is going to provide as it is an output pin like that way. So void setup, and then we will select this pin mode like whatsoever we have done. We will select pin mode of LED pin as an output. Okay, output I have written, and then I'll close this setup. So in this one we have like selected this 13 pin, that is LED, this 12 number pin as an output pin. Okay, so after that we will be writing a loop function. Okay, in your C and C++, there is that main function. Like that way only, in this Arduino ID, there is a loop function. This loop function will run continuously. Once the setup is done, then this loop function will run continuously until and unless there is no break statement or something to terminate. Okay. So in this loop function, what we'll write, we will we need to digitally give this input to the 12 number pin. Okay. So I will do digital write. Okay, digital write to LED. LED pin, LED here means on 12 number pin, I will be giving digital write, and I will make this pin as high so that full 3.3 volt is going to this LED. Okay, and then I will close this. So as of now, like let's see if this code is running or not, or the errors we are getting. I'll see. Okay, uh, okay, so to start the simulation, we need to click on start simulation. And once it will be initialized. Okay, see I have not closed this line. It's a simple semicolon. Then again I will be start the simulation. So see our this LED is turned on, right? Like at first it was off, and now it has been turned on. So this loop function is running continuously. In this loop function, we are not told this LED to be turned off, right? So that's why this LED is continuously turned on only. So now we will make some changes also in this code. So I'll first stop the simulation, and then I'll add a delay for this code to stop for 1 second. Okay, to stop for 1 second, you need to enter 1000. Okay, so add a delay of 1 second, and then at first I was adding this LED to be high. Okay, for 1 second. Okay, it will be high for 1 second, and now here I will add low so that no voltage will be given to this LED for 1 second, and then again it will go to digital write LED high. Then again it will stop for 1 second, and then again it will be turned off. So it will blink continuously one after one. Okay, so now I will start the simulation. Okay, so now you can see after 1 second it is turned on, 1 second off, 1 second on, 1 second off, like this way. Okay, so I'll change the. If anyone was not able to make this LED uh, program, then I'll share the link also. No problem in that. Okay. So I'll stop the simulation and I'll send it to create a link for this. I'll copy this and I'll ask him to share. Okay. Okay. So whosoever was not able to make this wants to see this code, like the link I have shared. Tarun, can you please share that link in the chat box so that everyone can see? Like when you will click on that link, then you will be asked to there will be an option like copy and tinker. Okay, then same this program will you will be able to see. Okay, same this program, and when you will click on code, and the whole code you can also see. Okay. Okay, so once you have clicked on copy and tinker, then you can see this code also. Okay, if you want to see this code, I'll zoom also. No worry. Wait. Yeah, this is the code. Okay, if you want to write and if you are doing side by side, then you can write the code and you can move on. You wait for 30 seconds, or you can take a screenshot also. Okay, the link which you are getting in the chat box, you can simply open that link and click on that copy and tinker. Okay, so that same circuit which is available on my screen is which will be available with you guys also. Okay, so see this our blinking LED program is done. Now we'll start with another function. Okay, another basic component that is our this ultrasonic sensor. We will be doing something with ultrasonic sensor. Okay, make new circuit. It takes some time to reload again. Create a circuit. Okay, so now we are making this ultrasonic with the Arduino. Okay, okay. So first of all, same thing. Now this time we are going to use one more this basic like science component in this, which is breadboard. Breadboard. Okay, I'll take this breadboard and put it over here. You can simply search your breadboard and you can get it. Okay, it will take some time. Okay, okay. Okay. Now the next component is our Arduino, which is the main component. Okay, I've taken Arduino. Okay, Arduino is here, and then we'll be requiring one ultrasonic. Okay, ultrasonic sensor. Ultrasonic sensor. You can place it on this one also. Okay. Okay, I have attached this ultrasonic sensor. Then like what I'll be doing, like we have used LED also in use, and this time also we will use. I'll tell you how we are going to turn on this LED. Okay, so again one resistor also will need. Okay, that is resistor, and then what else is left? Okay, now just connections are left. So this black wire I'll take first. I'll connect the cathode part of this LED to here in this black line part. See in this breadboard, if you connect any, like if you will put this ground connection to this breadboard, na, like if you will put this ground to this line, then whole this ground connection is will be available in all these connections. Okay, so you just need to put one pin over here so that every sensor can access the ground pin. Okay, and same goes with this plus 5 volt also. Okay, I'll take this plus 5 and I will give it to the plus 5 line. Okay, and I will change the color to red. Okay, so it's not confusing. Okay, so I have given the plus 5 to this breadboard. Now every plus 5 volt or everywhere where you need plus 5 connection, plus 5 volt, you can get it from here. Okay, so now we'll connect this ultrasonic sensor. See, in ultrasonic sensor there are mainly three things. Okay, ground, 5 volt, and SID. Here SID means ping. Okay, in this ultrasonic sensor, this SIG pin only will be giving us data. So first I will connecting this ground to this ground of Arduino, right? I have connected this ground in this line of Arduino so that everywhere from everywhere we can take ground from this line. Okay, and plus 5 volt I will connect it to the plus 5 volt. Okay, I will change the color to the red, and then now this data pin. Okay, we need to connect this ping pin. I'll take that. And suppose I'll connect this pink pin to pin number 7. Okay, pin number 7. And I will change the color. Okay, so no confusion is there. And I'll connect this LED to this one, pin number 13. Okay. Okay, so our circuit part is done here, and now we'll be writing the code for this. Okay, how to get the code? So same thing which we done previous time. Oh, okay, okay. Only then we can continue. So here you can see it already gives us in boiler plate code of this LED. Okay, so we'll use the same only, and we'll add some variables. Okay, so first I need to declare one constant integer variable. Okay, for these ping pin and LED pin. Okay, for ping pin where I have connected this ping pin I have connected to the pin number 7 of Arduino. Okay, so I declared this to 7, and then for this LED I will declare another variable that is 13. Okay, 13 I will declare, and then in setup we need to like here we will be using our serial monitor also. This is our serial monitor. So whatsoever data will this ultrasonic sensor will be getting now, will be getting in this serial monitor. So in order to use the serial monitor, we need to give a command serial dot begin, and Arduino works at 9600 baud rate. Okay, so we need to give this command for sure, and then we need to give this LED pin as an output pin. And see, here it is written like our previous code, it was LED written like it is the default one, but we have declared our LED pin as LED. Okay, so simply LED will write, and will we are given this LED as LED pin. Okay, and then we'll write our loop function. So delete this whole code, and then you can start your code. So at first I'll declare two variables, that is duration and centimeter. Okay, these both variables I've created so that it is easy for us to calculate the distance in centimeter, because what does this ultrasonic does is like it sends an ultrasonic wave and it calculates the time taken by that wave to come again back in this hole. Okay, it will calculate, it will measure that in the terms of time, and we know that if like distance is equals to like speed is equals to distance upon time taken, right? So from that formula only we'll be calculating our distance. Okay, so distance, right? So once we have this we know the speed of ultrasonic sensor also, and we know that what is the time taken by this ultrasonic sensor. Okay, we will be getting from this ping pin only. So for that purpose only we are declaring these both variables. Okay, so now we'll start. So at first I'll do pin mode of this ping, ping as in like output pin, okay? Submit capital, yeah, output. And then again, I'll do this pin mode, like a pin mode of this thing only, pin mode of pin as input, so that it can take input also of that incoming wave data, okay? Input. And here we need to delay this also so that it for sometimes the wave we can show, okay? And here we'll add digital write also in the ping pin. Ping pin. Mhm. We need to first do that as low so that it will send the wave. Okay. Okay. Then again we will add one delay in microseconds. Delay in microseconds. We'll add a delay for 2 microseconds so that one by one only it will show, okay. And then we will again send the data from this ping pin, okay, as high. At first we have turned it off and then again we'll turn that on. Okay, now it will be high. Okay, and then again when delay of microsecond. Okay, and then I'll like again it will be low only. Okay, and then once this all data has been collected, and now we need to print that data on this thing serial monitor. Okay, so from the same thing, uh, wait. Digital write first will do digital write, and then an input. Okay, and before this we'll add this. We'll declare this as an input pin. Okay, as an input, and then we got the data. Now we'll be getting calculation. Okay, we'll give the value to the duration as this thing pulse in. Okay, pulse in is the inbuilt command of to use to get the data from the ping pin. Okay, and pin when it is high. Okay, we got the duration also. Now we'll convert it into the centimeter. Whatsoever duration is there, I'll convert that. Okay, so for that we need to create one function that is microseconds to centimeter, and we will pass an argument of this duration to that function. Okay, after that, now we need to print all this data in serial monitor. So it is dot serial dot print. Okay, it is simply print. First, will be printing distance. Okay, distance, and then again I will close, and then again serial dot print. Now we'll display the centimeter variable. Okay, I will pass this now serial dot serial dot this thing, like now if we simply print this, then it will be coming in a single line. Okay, now we need to add an enter also, that will use serial.print command itself, and then it will be done. Okay, so now I need to make this function. Okay, this microseconds to centimeters. So I'll make this function first. So long I will take, so because I want written as long type. Okay, and it is expecting and is expecting and long only. Okay, and microseconds I will take microseconds, and then I'll return this microsecond as return micro. Let's copy this by microseconds by 29 by 12. This 29 by 2, like how we got is like this speed of like ultrasonic, like what is the traveling speed of this ultrasonic waves? We know that from earlier only. Okay, so this 29 by 2 came from there itself. Okay, so like this is converting this microseconds to centimeter. Okay, and we'll send it to this function, and we are accessing this function in this line centimeter is equal to this. So we'll first compile this and see if any error are there. Okay, we got an error. What is this? This void loop digital. Okay, right, spelling is wrong. Okay, okay, now expected. Okay, here we have not put a semicolon. Okay, that's it. Now again I will start the simulation. Okay, already showing now. Okay, here also right spelling is not correct. Okay, so now it is working. Now I will open my serial monitor. Now see, it is printing the distance. Okay, now use this ultrasonic sensor. When I will click on this and I will move any object, right? Just a minute. Okay, see this. It is showing distance. It is changing the distance, right? Now it is going. Okay, so I will first stop the simulation. Okay, now what we need to do, if this distance is less than this, I'll add an if else condition. Okay, if the centimeter is less than 100, then this LED must turn on. Okay, so I'll write digital right LED pin as high. Okay, and whenever this else, if it is more than 100, then it will be off. Okay, okay, else digital right LED was low. That's it. Okay, now let's see. Okay, see now the distance we are getting is 57, and you can see this LED is also turned on. Okay, LED is turned on, right? Now, suppose if I move this, wait. So see when I move this on more than this thing, like 100 centimeter, now distance is coming as 331 centimeter. So that's why this LED has been turned off. Okay, okay. So I hope it is clear to you. Now, one last project we will do. Like I'll share this code also with you guys. Okay, I am creating this link and I will share this. Okay, on chat box. Okay. Now please share this code on this this one in this chat box. Okay. Okay. So when you will open this link also, then again you will be able to open this. Okay. Like you will be able to copy and tinker. Okay. Copy and tinker in your own system. The same thing which you did with this previous LED program. Again you can do. Okay. So at the end, I'll also send you this project like which I have created for you in advance. Okay. Okay, it's loading. Okay, so we'll make this thing. We'll do this one water level using ultrasonic. Okay, I'll tinker this. Okay, this one is loading. Okay, okay. Now, like first I will share it with you guys so that you can do this. You can also open this in your system, and in this I will share explain you how I have done this. Okay. Okay, code you guys want to see. Wait, I'll go back. Okay, I'll share the code, like I'll zoom in the code so that you can take a screenshot. Also, no problem. Okay, okay, you can take the screenshot of the code. Right, it is visible, right? Okay, so I hope you have taken the screenshot. Now I'll go back, okay, in that previous that water level measuring using this ultrasonic sensor, okay? Okay, now, yeah, water level using ultrasonic. So now you can continue. I've shared this water level using ultrasonic code also in this chat box. You can access, simply open this and make a copy of this, okay? It takes some time from the Okay, so now it is there. So first I'll explain you the circuit, how I made it, okay? So the same ultrasonic sensor I have used, okay, it's ground and plus 5 are connected to the ground and plus 5 of this Arduino, and this pin I have connected to pin number 7. And then three LEDs I have used to indicate the level of the water. Okay, if it is red, then it is full. Yellow, then it is about full. And like when it is green, then there is no need to fill the tank. Okay, and if it is yellow, then it is an intermediate level. And if it is at red, then your tank is full. And whenever full, this buzzer will buzz. Okay, so I'll show you the code. Here I have declared all these green three LEDs and three LED pins, and this buzzer pin also I have declared. And then I have declared two variables for this ultrasonic sensor also. And in void setup function, I have declared all this pins as output function. And to read this ultrasonic sensor data, I have used this code. And in loop function, same thing. I'll print this all data in serial monitor also. And if the distance is less than 100 centimeters, that is, if this water is less than 100 centimeters, okay, then it will turn on the green light. And the water level, if it is between 15 and 100, okay, then it will show us yellow light, okay. And if it is in between 25 and 50, then it will show us like this thing, red light, okay. And if it is less than 25, then it will buzz the button, or like the buzzer will be turned on, okay. So I'll start the simulation and I'll tell you how it is working. Okay, so this is simulation is started. Now if I keep this as a, oh, what is the distance now? Okay, just a minute. Just a minute. It is got stuck in this laptop. See, now the distance which I'm getting, this much 83, right? In this this LED is turned on, right? These all are switched off, and this is getting turned on and off, right? As you can see. Okay, this yellow, like now the tank is in at intermediate state. Now, if the distance is this much greater than 100, okay, greater than 100, I'll do put it here. Now the distance coming is 275. Now see, you can see the green LED blinking, right? Okay. Now I'll put it in red light mode. Then it is 25. Uh, it should be less than 25. Make that this thing. If it is less than 25, then this budget that will turn on. Like the tank is full. It is indicating that the tank is full. Okay, and you need to turn off that motor. Okay. So that's it, right? Guys, I will stop the simulation, and I have already shared this code with you. And now we'll move on to like what other projects you can make with when you have an Arduino. Okay. Okay. Now I'll share you this screen again. Just a minute. Um, I hope this screen is visible to you. Okay, I'll wait for some time. Okay, it's loading something. Sometime. Okay, so this was a like this Arduino smartphone controlled car which I made in one of my hackathons. So I'll play this video. See, like at first I will be connecting this car through my smartphone. Okay, then I move this car and I'm connecting like using pulling this car from my smartphone. Okay. And in this car I use this motor controller. Like the Arduino is below beside this motor controller. If you also want to see this video, you can see that I shared the link. It was lagging on my screen. Okay, just a minute. I'll share my screen again. Okay, like you can see this video also. Okay, like I shared in chat box, and I'll play also. Like if it's lagging, then you can go through that link and see that video on YouTube. Okay, I'll first connect this card through my smartphone using the Bluetooth module. Okay. Okay, once this card is connected, then it will lower down the link is okay. So I'll move on to the next project. Okay, you can see this voice control car. Like you can also I made like I use an inbuilt app library only. Like you can convert your voice to text commands. Okay, by that also you can do. I use the same thing only. I'll play that video also. And I'll share this link to in chat box so that you can see.
Go forward.
See, I've given the command of go
Stop.
forward. It will
Stop.
go forward and then it will stop.
Go backwards.
Stop.
Stop.
Turn
Turn
right.
right.
Stop.
Stop.
Go
Go
forward.
forward.
Stop.
Stop.
Turn
Turn
left.
left.
Stop.
Stop.
Go
Go
backwards.
backwards.
Yes, it's no.
Stop.
Okay, that's it. Now, like I'll see come on to this questions part. Okay, and once if you want to see this project on GitHub, then also you can see. I'll share how to see that I'm moving this project to team code timings and GitHub repository. Okay.
Yes. Now we can address the question.
Yeah, yeah.
Yeah.
So I can see. Wait, first I'll move
Yeah,
this file.
Manoj. In real world, would be the components connected to PC and the code would be compiled by the PC, right?
Yeah,
Like when you code in IDE, Arduino IDE, it compiles the code, send it to the Arduino memory, and like it converts it into a language that Arduino can understand. Atmega 328 chip can understand. Yeah. Next question. Open source
yeah.
hardware. Hmm.
Yeah, like this Arduino is an open source hardware only. Like
Hmm.
when you are using this Arduino IDE, it is open source only. Like anyone can download it for free. There
Huh.
is no charge for it. Okay.
Also, and like Arduino, it is not specific that those only components can be embedded on the Arduino chip. Like you can make your own Arduino board also, so it is completely open source.
Yeah. And one more question I can see is what
Uh,
steps are being taken to ensure
the
privacy in.
the major like the most important step is that key like when IoT devices send data over the internet, it should be in highly encrypted form. That is the like major step that should be taken by the IoT devices. Like
And,
hmm,
yes, and one more thing, you guys would have heard about IoT and blockchain, right? So, like, it is in developing stage only. Like, whenever the data is being stored in the blockchain, it is very difficult to hack and very difficult to like change that data out. Okay, so that when this data has been sent on any blockchain network, and from blockchain network only we are accessing that data, then it is in highly encrypted mode, right? No one can change that data. When blockchain is enabled in IoT devices, then it is possible. Okay. Now, next.
hmm.
Yeah, next question. Okay.
What is the best way to start my hardware journey? You can definitely start with Arduino. Like it is very easy and like easy to understand for beginners. Basic syntax of C, C++, and all that.
Yeah. Like the first thing, like if you don't want to buy Arduino for like rupees, it comes around rupees 350 only. You can buy that. Okay, but
First copy of it. No, don't buy the original one if you
yeah, don't
can't.
buy the original one because it will cost you so much. But first, you can simulate it online, like I did in this Tinkercad, right? So using Tinkercad, you can first simulate it in your online mode, and then you can go for the this original ones. Okay, like if you want to try it at home, then you can start with some linking programs, and then you can move on to different sensors, right? As the things goes, and like I made this car after learning about all those sensors. Okay, so by that way you can go.
Yeah,
Okay,
I guess
next.
these were the only questions.
Yeah, and
What are the
guys.
real world uses of Arduino? Is it used for only for simulation? Like Arduino is a very like it has very small components. It can't be used in real world, but yeah, for experiment purposes, it is used. Like for like if you want to make a small project for your demonstration purpose, it is used not in the real world. There are
Yeah,
specific processors, the
like
microprocessor
there are
used for
different
that.
kinds of microprocessor. Like Raspberry Pi is one among the like, best microcontrollers which we use. Okay, so that like, because Arduino has it's its own capacity, right? Like it can't handle more than 5 sensors at once. Like if you buy the original ones, then it can handle, but clone versions they will simply like will convert into an defective piece if you give more load on that. Okay, so for basic components, you can use Arduino. Uh, like
It is a small chip. If you give more load to it, it will burn. Like
yeah.
can't be used in real world. Definitely not.
Mhm. Okay. Is Raspberry Pi different from Arduino? So like Raspberry Pi has its own capacities, like right, like you can run a simple Kali Linux on your Raspberry Pi microcontroller. Okay, okay. So Arduino is the child, and this Raspberry Pi is father of Arduino. Like, in that way, it
It
will
is
be
more
more.
advanced version of Arduino, you can say.
Yeah, like you can control n number of sensors. Like you can control your whole home automation from this Raspberry Pi. Okay.
You can say it is like a mini computer, like
Yeah,
very low power computer.
and I'll share the link of that project also if you want to see and have a look on that defense board which I shared. I'll share the link also. Okay, next question. Okay, if there are no doubts, then we can over
Yeah.
end this session. Thank
You
you,
can
guys.
definitely fill the feedback form given in the chat, and that's it. Fill it for attendance. Like
Yeah, and if anyone of any doubt occurs after this session, then you are always free to contact me. I shared my GitHub link also, right? You can contact me through there or anywhere.
okay, thank you guys. Oh, all right, bye bye.
Bye.